they occur, an organism miscalculates its size and makes a smaller version of itself. These smaller versions are like new species of life. In a rainforest, it's believed that new species are formed in a similar way. When parents reproduce, their offspring are not exact replicas. There are slight mutations that make each individual different. Over time, it is believed that changes can build up that are so dramatic that a new species is created. This theory is called evolution.
One way that I like to think about evolution is to think of evolution as an artist. To me, it's the best there is. The artistic creations of evolution are incredibly beautiful and complex. Imagine a hummingbird pollinating a flower, or a cheetah running down its prey, or the human body. Those are fantastically beautiful things.
Ray believes that if evolution can create rich diversity in the real world, it can also create diversity inside his computer.
So I sort of play the role of setting up the studio for evolution to create its art in.
For months, Ray designed a single computer organism. He called it the Ancestor. If his experiment worked, he'd actually see the ancestor evolve into new species. Late one night, Ray loads the ancestor. Seen here is a red line into his computer. With the click of a button, the ancestor comes to life, and to Ray's surprise, it begins to reproduce rapidly. New species are born quickly, seen as different colors. Inside the computer, life flourishes. Death strikes the old and the weak, making room for future generations.
That night, the first time that it ran, I got a pretty rich evolution, which surprised me and surprised everybody. I got hundreds of mutant versions of the original program that survived. In a few hours, the original ancestor evolved into a tree of digital life, a whole array of different species that are all connected, just like organic life on Earth.
With every second, the digital life is getting more complex. It's becoming more advanced. And to Ray's surprise, creatures are behaving like the creatures he saw in the rainforest.
What I saw that I knew from organic life was that we had interactions between the different species, like cooperation and cheating and lying and stealing.
Given the right conditions, Ray believes his creatures will continue to evolve. And it is possible, according to evolutionary theory. After all, life on Earth may have started as simple bacteria and algae.
If all we know about digital organisms are the equivalent of algae and protozoa, I don't think we can really fully envision the possibilities that are out there. It could be that evolution can reach a comparable level of complexity in the digital medium, in which case it would be truly fantastic. The excitement is about the potential. We're venturing into the unknown.
A mathematical recipe executed in the computer may be starting a new age of invention and discovery. Using mathematics, a computer screen may turn out to be a window into another world. For centuries, life on Earth has defied mathematical description. Mathematics' rigid rules could not capture the essence of life, its detail and complexity. But things are beginning to change.
Math has to become a bigger part of biology. We're just beginning to understand how animals and plants are designed.
Some of nature's most spectacular creations have been modeled using mathematical equations. Simple rules, it turns out, can lead to dramatic complexity. Mathematics is giving us a new way to see the invisible, revealing secrets that can improve our lives.
It's remarkable to discover how many connections mathematics makes, how many light bulbs it suddenly turns on in your head.
Exploring nature with mathematics is a new frontier. Everywhere we look, there are questions to be answered, mysteries to be solved.
It really is a very exciting time to be a mathematician who works in biology. And I do find it quite difficult not to look at a fern or the bark of a tree and wonder how it was formed. It just seems to me that there are so many questions that one would like to know the answers to.